Hey guys. All right, a particle moves in a straight line. Its velocity at time t seconds is given by v equals t squared minus 4 cubed when t is between 0 and 3 seconds inclusive. So 6a says find the velocity of the particle when t equals 1. So they gave us the velocity function, and we're finding the velocity when time is equal to 1. So it's just a simple substitution problem here. v of 1. And that's going to give us 1 squared minus 4 cubed. That'll just be negative 27 meters per second. All right, let's check out 6b. Find the value of t for which the particle is at rest. So we know that a particle is at rest when v of t is equal to 0. So let's take that velocity function and set it equal to 0. Cube root both sides, we would just get t squared minus 4. That's a very easy one to factor. We would get t is equal to negative 2. T is equal to positive 2. Now let's consult the interval one more time. The interval is when time is between 0 and 3 seconds. Negative 2 is not in that interval, so we are going to reject negative 2 and keep time is equal to 2. Okay, so this is where the velocity is equal to 0. 6c. Find the total distance the particle travels during the first 3 seconds. Okay, so 6 is a calculator question. I forgot to mention that. Okay. It is a calculator question. So for this question, all we would do is just go ahead and take our time interval, right? We're going from 0 to 3. We want to find the total distance traveled. So we take the absolute value of the velocity function. The velocity function is given. So it would just be entered into the calculator just like this. And you can pause it, type it in your calculator, and then come on back. Did you get 86.3 meters? High five. 6D. 6D says, show that the acceleration of the particle is given by a is equal to 6t times t squared minus 4 squared. This is a kinematics problem. So if we are given the velocity and we need to get to the acceleration, we're going to have to take the derivative of the velocity to get us to that acceleration. So to take the derivative of the velocity, what we're going to have to do here is a simple chain rule. So we would have that 3 coming down out front. We're going to keep the inside as it was, reduce the power by 1, and then multiply it by the derivative of the inside. So my acceleration function now becomes 6t times t squared minus 4 squared. All right, and then 6e. 6e says find all possible values of t for which the velocity and the acceleration are both positive. So remember, when we're trying to find the sign of the acceleration or the velocity, we're going to make a number line, just like we used to do with the sign of the first derivative and the sign of the second derivative, because velocity is just the first derivative of the position function and the acceleration function is just the second derivative of the position function. So both intervals begin at 0 and end at 3. And now let's find the critical points for each number line. So velocity is equal to 0. We just found it in 6b when time is equal to 2. And then acceleration has the exact same like algebraic structure here. You would just set the 6t equal to 0, and that would give you t equals 0, which is already being used. And then you would set the t squared minus 4 squared equal to 0, and you would get t equals negative 2, t equals 2. Reject the negative 2, keep the positive 2. So then now we just have to test the sign. Let's go to the velocity function. If we tested a 1 here, we would have 1 squared minus 4, which is a negative number, cubed, which is a negative number. For the velocity function between 2 and 3, if we did 2.5 squared, that's going to be larger than 4. That's going to be a positive number. Cubed, that's going to be a positive number. On the acceleration function, if we plug in a 1, we would have 1 times a negative number. That would give us a negative. And then if we plugged in that 2.5 again, it would be a positive number times a positive. So now we have found that the possible values of t for which the velocity and acceleration are both positive is t is an element of all reals such that t is between 2 and 3. And we are not including them because at 2, it is a critical point. It is not positive or negative at 0. And then at time is equal to 3, at 3 it is positive. It's the end of the interval. So we could actually go ahead and include that 3. That's fine. There we go. The end.